Hello, this is Systems of Linear Equations and Inequalities, Linear Programming, Example 3. And Example 3 is a story problem. It's extremely difficult because we have to figure out the equations and inequalities this time. In the last questions, they gave us the objective function, and they also gave us the inequalities that made the region. Here we're going to have to figure all that out. So it's pretty complicated. They're talking about making bicycles, and they talk about the general labor that it takes in plant A and plant B, the machine time in plant A and plant B, and the technical labor in plant A and plant B in this table. And it also says the general labor can be up to 4,000 hours. Machine time can be 1,500 hours, and the technical labor can be 2,300 hours. And the profit is $60 per bicycle in plant A and $50 per bicycle in plant B. Well, looking at this, I'm sure it sounds impossible. I'll try to explain it, but you just got to take it apart a little bit at a time. I let A be the number of bikes that plant A makes, and they get $60 profit for that. And B, the number of bikes that plant B makes, and they make $50 profit for that. So we can get the objective function from this. The profit is $60 for each bike that A makes. That's 60A plus 50B. So now we have the objective functions, and so what we still need to come up with are the constraints. And here, general labor, it's 10 hours per bicycle in plant A. Well, A is the number of bicycles. Lowercase a is the number of bikes from plant A. B is the number of bikes in plant B. So it's going to be A times 10, B times 1. And when we add up the general labor up here, it says that that can't be any greater than 4,000 hours. So, like I said, we're going to take 10A plus 1B, and that has to be less than or equal to 4,000 hours. And similar here with machine time. This is 1A plus 3B, and that has to be less than or equal to the 1,500 that they talk about in the story problem. And the technical labor, that has to be 5 times A, and this is 2 times B, so 5A plus 2B, and that has to stay less than or equal to 2,300 hours. And also A has to be greater than or equal to 0, and B has to be greater than or equal to 0. So, based on the story problem here, we have figured out the objective function, and we've figured out all of these constraints on the region, and when we graph them, the graph looks like this. Here's A greater than 0. Everything above this line is B greater than 0. And when I graph these lines, I come up with these boundaries. And the boundaries have these points. It's the point 0, 0, 0, 500, 300, 400, 380, 200, and 400, 0. So when you plug all of these in and work everything out, plugging these values for A and B into the objective function, it works out that this point right here, A equals 300 and B equals 400. That's where the maximum occurs. The profit there is $38,000. And when you try all of these other points, well, 0, 0, of course, there's no profit. When you put in 0, 500, you get $25,000 profit, and different amounts for each one of these, but this is the one that works out to be the most profitable for the manufacturer. He makes the maximum is $38,000. That's 300 bikes from plant A and 400 bikes from plant B.